You most likely remember studying and learning about exponents in school, and you've likely noticed the concept coming up every now and then in your job or other aspects of your life that involve counting. Exponents are to multiplication what multiplication is to addition. We know that 2 to the power of 2 is 4, we know that 3 to the power of 3 is 27, and we generally know why it works this way. But one thing we never really have to deal with because it doesn't come up much in the real world is what is anything to the power of 0? You may remember from math class that anything to the power of 0 is in fact 1, but why is this? It doesn't really seem to make sense at first glance. Why wouldn't anything to the power of 0 be 0, the same way that anything times 0 is 0? After all, exponents involve multiplication. Most people think of exponents as representing the base times itself the exponent number of times, so 2 to the power of 3 is saying 2 times itself 3 times. But it doesn't mean that. Multiplying 2 by itself 3 times would be 2 times 2 times 2 times 2. And this is 2 to the power of 4, not 2 to the power of 3. The exponent actually represents the amount of things there are, but what are they being multiplied by? Well, 1. When you say 2 to the power of 3, what you're really saying is 1 times 2 times 2 times 2. There's this invisible 1 there that nobody writes down, and for a while nobody knew existed, but it has to be there for exponents to work the way they do. So when you say 2 to the power of 0, what you're essentially saying is take 1 and multiply it by 2 0 times. Not 1 times 0, mind you, but just take 1 and don't multiply it by anything. So you're left with 1. But this wasn't known from the start. Originally, exponents were used to count things, usually growing amounts of things. Apples, increasing populations of people, growing money in your bank account. Powers of 0 never really needed to be considered, so when mathematicians started being presented with this problem, they knew they needed to do something to figure it out. What is 3 to the power of 0? And they did this by working backwards. For just a second, let's forget that we know anything to the power of 0 is 1. Let's put ourselves in the shoes of the mathematicians who were initially tasked with figuring out this conundrum. Let's take something like 3 to the power of 4. Well, that's 3 times 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So 3 to the power of 4 is 81. Now let's find another way to arrive at this value with a different equation. What we know is that for every number that the exponent is increased by, we're multiplying once more by the base. So if we had 3 to the power of 5 and we needed to do something to it to make it equal 3 to the power of 4, what would we do? Well, we could simply divide it by the base, because 3 to the power of 5 has 1 more times 3 in it than 3 to the power of 4 does. So if we divide by this base, we cancel out that. We're basically subtracting 1 from the exponent each time we divide by 3. So 3 to the power of 4 is the same as 3 to the power of 5 divided by 3. They both equal 81. So the rule here is that each time we increase the value of the exponent by 1, we simply have to divide that equation by the base to keep it the same, to cancel out that increased exponent. Let's work down from this and try to get the values in the middle by using these equations on the right. 3 to the power of 3 is like saying 3 to the power of 4 divided by 3. We know these will equal the same thing because the exponent is increased by 1 and we're dividing by the base to cancel that out. So we know from the rule above that 3 to the power of 4 is 81, and 81 divided by 3 is 27. Now how about 3 to the power of 2? Again, let's put this equation on the right and do 3 to the third divided by 3. Well, 3 to the power of 3 is 27, and 27 divided by 3 is 9. Going down again, how about 3 to the power of 1? Using the same pattern, 3 to the power of 2 is 9, and 9 divided by 3 is 3. And here we get the reasoning for why any number to the power of 1 is always itself. And now let's go down here. We arrive at 3 to the power of 0. Going to the right side equation again, we just established that 3 to the power of 1 equals 3. So what is 3 divided by 3? It's 1. So regardless of what your base is, whenever you follow this logical pattern on the right equation side down to 0, you will end up with the base divided by itself, which is always 1. Now there is one exception to this rule, one single number that when used as the base and sent to the exponent of 0 might not equal 1, and that number is the usual culprit, 0. As this video has shown, the number 0 has a tendency to overcomplicate things that should be simple, and it is still debated today among the world's leading mathematicians whether 0 to the power of 0 equals 1 or 0. Keep in mind, this is not the only method of proving that powers of 0 equal 1, and if you're interested, I encourage you to go look through more of them. All of them are quite fascinating, and this concept also helps for understanding why negative exponents result in fractions of 1.